video, we are going to make a system of linear inequalities based on what the graph gives us. How do we do this? Well, we basically go backwards by first looking at each individual linear inequality. So I'm going to focus on each line, and then based on the shading, come up with the proper inequality sign. And before you know it, we will have built ourselves a system of linear inequalities. So what we have here is, let's start with the orange one. Right, so I've got a line, and we first need to figure out what the boundary is. And the boundary is this line right here, and it looks like the y-intercept is right here at -2. So what I'm going to do is, I'm going to start out by saying, okay, I've got -2 as like a y-intercept, and then my slope goes up 1, 2, 3 over 1, up 1, 2, 3 over 1. So with slope-intercept form, I get 3x minus 2, and you know what I'm going to do is, I think I'm going to write that a little closer. So 3x minus 2. Now that's going to be y equals, except, which way are we shaded? Well, we're shaded below that graph. So it's going to be all the y values less than or equal to this line. And you can do a test point. If you plug in 0, 0 into this thing, 0 is less than or equal to 0 minus 2 is false. 0 is not less than -2, so we should shade away from 0, 0. So hence, y is less than or equal to 3x minus 2. And that's it. You're now done with the orange part. So now we're going to look at this color right here, which I'm not sure if it's blue or purple. I'm colorblind, so we're going to go with the bluish purple color. Anyway, the dotted line right here, well, what is the boundary? Well, we have a y-intercept of 0. Okay, so I'm going to kind of write off my thoughts to the side this time. B equals 0, and what's our slope? Well, we go down 1, 2 over 1, 2, 3. Or from this point, down 1, 2 over 1, 2, 3. So that's a slope of down 2, right 3. So that boundary is y. It would normally be equals -2/3 x, but we're not going to write equals because we've got a dotted line. We are shading above that dotted line, so it's all y values above it or greater than the line -2/3 x, and we do not put an or equal to because it's dotted. And that's it. Now you could test to make sure we're right with this. So let's pick a test point from the region where both shaded areas overlap. So I don't know, a really easy point would be somewhere, let me change the color right here. It would be somewhere like right here at 5, 0. That'd be a nice one to plug in. It's definitely in the region. So I'll plug 5, 0 into both of these equations. Inequalities, I should say. Into the first one. So if I test 5, 0, I'll put 0 in for y. So 0 is less than or equal to 3 times 5 minus 2. And the question is that true? Yeah. 3 times 5 is 15. Minus 2 is 13. So you get 0 is less than or equal to 13. Yep, that's true. So we're good as far as the orange inequality goes. Let's go with the bluish purple one. So we're again going to plug in 5, 0. So we'll plug in 0 for y. So that 0 is greater than -2/3 times 5. Now I'm not even going to do the math. I'm just going to say a negative number times a positive is a negative. And 0 is greater than any negative number. So yes, that is also true, which means we have good inequality signs. All that's left is to make sure that our boundaries are correct, and we were very careful with generating those. That's it. So when going backwards and coming up with a system of linear inequalities, just go one inequality at a time, just like you did when you were going forwards and graphing them. That's it, peeps. That was a fun one. See you next time.